Chapter 9.3 is on separable equations. Now, what is a separable equation? When we're talking about separable equations, we're talking about some sort of a differential equation or a derivative function. Something like dy dx is equal to something. So there are lots of different variations of what dy dx could equal. There are certain ones that make them separable. And that's if you have a function with respect to both variables and it's a product. So you have a function with respect to x multiplied by a function with respect to y. If it's factorable, right, then it is separable. If factorable this way, f of x and g of y, then it is separable. And by that, we mean I can actually isolate the x's together. So I'm going to multiply both sides by dx and get dx on one side. And I'm going to divide both sides by g of y. And I'm going to get all the y's onto one side. So what I can end up doing is I can end up separating the variables and have the dy and the dx be multiplicative. That way, I can actually just simply integrate both sides with respect to each variable. So let's take a look at some examples. In this case, is this equation separable or not separable? Well, in this case, let's take a look. It looks like we have x squared divided by y squared. What I'm going to do is can I gather all the y's onto one side and all the x's onto the other and not make it additive or subtractive? So I'm going to multiply both sides by y squared to get the y squareds onto one side, and then multiply both sides by a dx, right? And move the dx over to the other side. So I get y squared dy is equal to x squared dx. And now all I have to do is integrate. We'll deal with the constants in just a little bit. Well, let's try the next one. What if I have something like this? Dy dx is equal to x plus y. Now, as you can see, this one, in order to get the y's onto one side, I would have to subtract a y. I get dy minus a y is equal to x times dx. On this side, it seems to be working very well, where you have x times dx. But in this case, you basically have a negative y plus a factor, or not a factor, a term dy, right? And this one I cannot integrate, therefore this one is not separable. So this is not separable, and this one was separable. Okay, now this last example here, let's take a look at one more, is a little bit more difficult to see. Because it looks like at this point, it looks like it'll be an additive. This is not factored in any way. But can we factor it to gather all the p's onto one side and all the t's onto the other? So you can think about it as you're factoring any other problem. So I can see that there's only two p's here. So I'm going to pull out that p. See what I get. I get t squared minus 1. And then I also have a t squared minus 1 here. What I can do is I'm going to group the last two together, and then I've basically created two terms with a common factor of t squared minus 1. This is a plus sign. So out of these two terms, I'm going to factor out the common factor of t squared minus 1. And what I'm left with on the inside of the parentheses is p plus, there's a factor of 1 in the front. There. So now if you take a look, once it's in its factored form, you can see that all my t's I can gather onto one side. So I'm going to multiply both sides by dt and get that on this side, and then divide both sides by p plus 1. And now what I can do is integrate. This one is a natural log, and this one is a regular polynomial. All right? So now this one was actually separable. Okay? So now let's take a look at some constants. In our example, in the very first example that we did, we had dy dx is equal to x squared over y squared. right? So when I separate the variables, I multiply both sides by y squared, get the y squared onto one side, multiply both sides by dx, and get the x squared, something like that. And what I can do is integrate. Now, if you notice, when I integrate, this is an indefinite integral. I do not have boundaries, which means I do have a constant. I have a y cubed over 3 plus a c, and I have an x cubed over 3 plus a c. Well, because they're close c's, I'm actually going to gather all the constants onto one side and say it belongs here. Where you put that constant doesn't necessarily matter when you initially put it in. Now, when they give you an initial condition, for example, they'll say y of 0 is equal to 2, then this constant and what you do with that constant and how you combine that constant starts to matter. So the number one thing about when you're given an initial condition is substitute it in immediately after you integrate. That is the best way to prevent yourself from screwing up this constant here. Okay? So sometimes you can actually solve for the constant, but this constant, for example, you can solve for y, subtract c to both sides, multiply both sides by 3, cube root that both sides, but you have to do the same thing to this constant every single time. So instead of doing that, I highly recommend that you plug this initial condition in immediately. Now, what does that look like? Well, it says that means in this case, remember this is your x value. So when x is 0, y is 2. So when x is 0 here, the y is going to be 2. So 2 cubed is going to be 8 over 3. So c will become negative 8 over 3. Now, once you do that, you can plug it back into here and then go from there. So you get y cubed over 3 minus 8/3 is equal to x cubed over 3. So you can solve for the y if that's the case. It looks like it's a function of y with respect to x. So multiply both sides by 3, add 8 to both sides, cube root both sides. So this would be what you get. Okay. Can we take a look? Let's take a look at what that looks like when I put the constant on the other side. So if I had put that constant on the other side is equal to x cubed. So from this step I integrated and then I added the c onto the other side. Is that okay? Well, I'm going to plug in that initial value again. So when x, this is going to become 8, 2 cubed, so it's 8/3 is equal to 0 plus c. c is now equal to 8/3, but positive 8/3, but I'm now plugging it into this equation. So then I'll get y cubed over 3 is equal to x cubed over 3 plus the 8/3, which is essentially the same thing. Right? And that's basically all you have to know about separable equations. Make sure that it's multiplicative, and then when you integrate both sides and you add a constant of c, you can add that constant anywhere. But when you solve for the c, please make sure you try to plug in those initial values immediately afterwards in order to prevent yourself from messing up that constant. And that's it.